Okay, so we start. I started this sharing on YouTube. So we have all the lectures shared on YouTube, so you can revisit them later. But today it's a pleasure to have Jane Hutton here for our seminar. And yeah, Jane, you might like to say a few words about you and how you came up with this kind of research, and then you can start the talk.
Great. I just realized I have actually updated this, but I didn't update the date on the front. So one of the things I've been interested in is what in statistics we would call lifetime data analysis or survival analysis. And so when colleagues at Warwick were working on COVID data and how long people will spend in hospital, they asked me to look at that. And so I've been keeping in touch and doing some of the analysis. And I guess as a statistician, one of the things I've always been interested in is what isn't there or what can go wrong. So this is partly about something that doesn't surprise me from general experience, but particularly not when people are under pressure, which is about the quality of what you can actually get. So one of the comments that actually came up today, a couple of hours ago, was related to the number of deaths in the UK from COVID. So there've been lots of BBC graphs which are like this, and they talk about COVID on the death certificate. Notice that COVID on the death certificate doesn't mean the person necessarily died from COVID. So you could have the instance of sort of, you know, the typical person who fell over and knocked their head and died, but a post-mortem blood sample found they had COVID. But one of the comments today was a colleague saying he's a bit surprised because the number of people who have died from COVID in the UK this year has gone down. So this is the cumulative total has gone down. He was very surprised. I was less surprised because I said, if they've done some careful study of the death certificates, they might well find that deaths have been attributed to COVID that shouldn't have been. So some of the areas I've worked on, like violent deaths amongst children or things like suicide amongst young people, you have to realize that there are a number of different ways in which that may be coded, because understandably a relative may not want to have a death certificate that they have to show to the bank that says their son committed suicide or that their husband died of cirrhosis of the liver through excessive alcohol. So there are actually ways in which things will be put that require experts to interpret them, and that would be my guess as to why there's been a drop. I don't quite know, what was it, from 38,000 COVID deaths to 37,500, say, COVID deaths. It would be the expert coders have looked at it and seen that the coding just doesn't make sense, and the death would not have been due to COVID. But we get all sorts of stuff about scientists say, you know, governments saying they're talking about science, and I'm aware that it's quite different in different countries. But what do you really want to do? And again, today in our catch-up, my colleagues were saying that they get people, first of all, the civil servants who talk to them change frequently. So they don't have the background, they've just been moved around. And secondly, they often just say, oh, tell us what you've been doing. Well, what I know as a consulting statistician is that one of the most difficult things to do when you're dealing with politicians, lawyers, medical doctors or whatever, is to help them to work out what it is that they actually want to know. Because they'll often say things like, how will it spread? What resources will be required? What is recovery? And you have to start taking them through the things that they know, but don't necessarily know they know, or they don't know, to say, well, when you say what resources will be required, are you just thinking of hospitals? Are you thinking of the implications, for example, for cemeteries? Are you thinking of the implications for unemployment? Are you thinking of hospital resources, not just for people with COVID, but for the consequences of domestic abuse after lockdown and so on? So in a what I would think of as an ideal situation, you have a dialogue to define the questions, and you might have to get people to realize you can't give them an accurate answer, and they've got a choice between an answer to the question they didn't ask, which might look accurate, or an approximate answer which will address what is actually important. And so one of the things, I haven't really kept up around the world with all of this because I've been so frustrated by it. One of the things in the UK is a lot of hoo-ha about test and trace. And because I was asked to referee a paper for The Lancet a little while back, I sort of read some of that. And there's a report from Imperial College London which asserts for PCR, sensitivity and specificity is about 80% and 100% respectively, and they cite two references. Well, I was unkind enough to go and read those references to see how on earth you got an estimate of 100%. Because I spent far too long working with diagnostic tests to find that easy to believe. And in fact, when you go and look at those references, the first one, you can either get a sensitivity of 65%, specificity of 81%. Okay, let me back off. Sensitivity is saying if the person has the disease, how likely is it that the test will give a positive result? And specificity is saying if the person does not have this particular disease, how likely is it that the test will be negative? So if you like, this is the question of probability of test positive given disease positive. Probability of test negative given disease negative. Now, one way of reading one of the cited articles was 65%, 81%. Actually, you could reinterpret their data to give you a 70-89 or an 80-93. But the second paper that they quote didn't have 1,000+ cases. It had 36 patients out of an original 204 who had COVID. And there were 50 odd patients who didn't have COVID. And the only thing that's mentioned in the paper is a sensitivity, a positive test given disease of 83.3%. Okay, and of course we can immediately, spot how few patients there are because 83.3 is your 34 and 36, or reverse of 2 and 36. But specificity isn't mentioned. But when I actually read the paper, the best you can get is 31.4%. So for your negatives, at most a third of them were testing negatives. The others were being recorded as positives. Now in the UK, you can look up Office for National Statistics things, and you find the prevalence in the general public was about 0.7%. In other words, from the general testing of the general public, you were saying that about 7 in 1,000 people had COVID. If you counted up over the past weeks, you could get up to 2.4% had tested positive at some stage, possibly with not distinguishing people who've had multiple tests. A more recent result talks about incidence rates in a week. There's a number of new cases in a week of 0.02% to 0.08%. Those are quite small numbers. So what? So why might this matter? Well, let's think about transposing the conditionals. If you have had a positive test result, what you should be interested in is what's the probability I've got the disease given that I've got a positive result. Now, of course, most people simply say the test is positive, therefore I've got the disease. And over the years I've been interested in this, there have been changes in things like cancer screening, so that, for example, now in the UK in breast cancer screening, the patient information explicitly admits that a positive result does not mean you definitely have cancer. But that is lost by these mathematical modelers like Imperial College. And so they say, well, all positive tests mean the person has COVID. No chance. Now I'm quoting the work they cited to justify their conclusions. As I said, if you actually look at that first paper, 65%, 81%, what does that mean? Well, if the true prevalence is 1%, that means of 100 people who get a positive test result, 3 of them actually have COVID. If I take the slightly more optimistic figures that you could extract from that paper, we can get up to 10%. 1 in 10 of the positives are positives. And there's a lot of comments I see around saying, oh, you know, there are lots of people who are asymptomatic with COVID. Well, maybe they're asymptomatic not with COVID, but they're asymptomatic with a positive test result, but they don't have COVID, which is why they don't have symptoms. If you actually look at the kind of prevalences we're talking about, and actually the previous page was 0.08%. So when I do 0.1%, I'm being slightly generous. We're really talking about almost all the positive results being false positives. If we say, well, let's actually assume it's rather worse, there's about 3%. Even if we're taking the best figures, we're only talking about 1 in 4 positives actually being positive. And if we use that other paper, we get even more depressing figures. I haven't included in here another paper that I read, which compared 7 of the commercially available tests. They only compared it in the lab, and then they did look at some clinical results on 13 people with COVID, and a mere 6 people without COVID. And on the basis of that, they conclude the test is perfect. I'm not convinced. So what is that going to happen? I'm now going to sort of swap more onto the hospital route. I'm going to use ICU to mean intensive care unit, which could also be high dependency unit or critical care unit. And if we're trying to think about what our hospitals are going to use, panic, there's going to be another breakout in December or in Leicester or whatever. Well, we need to know, okay, what hospital facilities do we need? We need to know the rate of people admitted to hospital, the rate of people who go into intensive care in hospital, how long they stay in hospital or in ICU. Well, is that all we need to know? Well, no, we could do with a bit more information. We're not going to assume people are all identical units. They're going to be different things that'll happen. How many beds does the hospital have? Staff, location. If you don't have enough staff, you may not be very willing to fill up your empty beds. Or equally, if you don't have enough beds and plenty of staff, that still gives you a problem. And your hospitals may or may not be particularly near where you want them to be. What about your patients? Well, age is almost certainly going to be important, as is sex. You know, in epidemiology, you break everything down by age and sex. It's almost invariably important. Pre-existing health is going to be important. Genetics might be important. What else might be important? Well, what about the community you're in? Because if most of us have had experience of older friends or relatives going into hospital, and we may have been concerned about how well they will be when they come out and what care they need. So you've got to think about rehabilitation and care home capacity. So maybe now we've thought of everything. Well, actually, no. Maybe we need to think about why people stop being in hospital, why their stay is ended. If we want to think rate of admission and length of stay and the factors, well, they might die. They might recover from COVID, and how are we going to define that? They might be marked as medically fit for discharge, but with nowhere to go. Or there may be space in rehab and care home. Or they may have to wait until their adaptations to their own home, because very often elderly people are functioning in their own home. But if they go into hospital for 2 weeks and lose muscle mass and also possibly get a bit confused, you can't just assume they can go straight back home without some adaptations and care. But I've seen analyses, more than I would like, who simply lump all of these things together and say, oh, well, that's that. Not a very good way of looking at the resources. So the data I'm using comes from a daily reporting system, part of the usual UK health reporting systems. Now, in Germany, you've probably got similar questions about patient confidentiality. A number of my colleagues are working on the fact that the General Data Protection Act was introduced, and then you have a pandemic, and people want information. Well, strictly speaking, you could have said, well, you can't have it. If I'm looking for information, as I land up doing for court cases, I will typically look to the Nordic countries because they have a different social attitude. They have very high quality data. We don't in the UK. We used to have, but we don't now because our government has made the choice, our society has made the choice that privacy is more important than accurate information. At the moment, I suspect the Information Commissioner has been gagged and tied up and locked away in a dark cupboard, judging by all the things that I see going on. So maybe people will rethink a little bit. Okay, so what information does one get? Well, they're weekly updates without personal identifiers. You've got sex, age, hospital. When I say half postcode, so in the UK, CV5 will tell you what sort of area of Coventry I live in, but it covers a lot of people. So it's not going to tell you it's me. If you went CV5-6, you would have a closer definition of where I live. But even then, not all that much. And of course, in the UK, there's been a lot of discussion about ethnicity. We have various lab dates, the onset, swab, test, type, results, and so on, various different tests. We get admission. Was it COVID? Where did you come from? A care home or a University Hall of Residence, date, ICU, and so on and so forth. Risk factors like, do you have asthma or pre-existing heart disease, or have you got cancer and you're on, or had a heart liver transplant, you've got immunosuppression, liver disease, obesity, and we get outcome and so on. All sounds wonderful, doesn't it? Well, frankly, as soon as I see something like that, I've got a pretty good idea of what we're going to see. Lots of data. There's a simple rule. Data quality almost invariably decreases as the amount you try to collect increases. I've actually looked in detail at 3 and less detail at 4 of the releases. So if we go back to the 23rd of April, apparently there were 102 fields coming from hospital and intensive care reports on 10,000 people. Well, that sounds nice, unless you're somebody like me who first and foremost looks at the quality of that data and says how much data is missing. Well, some data wasn't missing at all, but some data was 100% missing. And half the patients had at least 3/4 of the data missing. Okay, I'm not surprised. If you're in an intensive care unit and you're scribbling and making notes, or you're the person locked up in a dark room entering data, people are busy, they're under pressure, and they're not going to see any value out of this data. But if you start looking at it, this is the percentage of patients with missing data. 98% of patients, in the 90s have got 10 or 15 variables missing. So which ones are the ones that are completely missing? Well, the ones that were completely missing, defined by the software, were ones on ventilation and ECMO and travel. Now, travel doesn't bother me that much. To some extent, for this purpose, once you're in hospital, I'm trying to say how long you live there, where you've traveled to and from and got the disease is probably not important. But knowing whether you're on ventilation is really quite important if you're worrying about intensive care units. ECMO, well, realistically, it's very, very rare, so it's probably not that important. That's the point at which you circulate a person's blood outside of their body through an artificial lung. Very intensive, very expensive, and very uncommon. So maybe that's not so important. But those two, bit of a pity that it's missing. And those fields look as though they haven't got data missing, but doesn't help when you look at details. But when you look at some of these things that are really expected to be important, sex, ethnicity, cause of death, obesity, final outcome, hypertension, and so on, a large amount of that data is missing. So when you do a first pass, it may not show up as missing. But then when you actually look at the details, you'll find that you get lots of different categories of missing. Blanks, unknown, not recorded. So once we start looking at that, and we start looking, for example, at dates, lab test dates, well, hospital admission and lab test means money. You don't record it, you don't get the payment, so they tend to be quite good. That swab date, third of them we don't know when it was. Half the patients, we don't have a final date. We don't even know when records were updated half the time. We don't know when people went into ICU 3/4 of the time or left. And we can also say, well, how many people actually went to ICU? Well, apparently 39%. And so we can start saying, well, if we want to find out how long it takes from your having a swab and getting a test, well, 33% of the data is missing, but actually that looks quite good. If we know when it happened, it's you get a test within 0 or 1 days. If we say how long is it from your test to admission, seems to be peaking around a fortnight at this point. But how many people actually went into admission? Well, apparently 3,994. But if I start looking at whether it says yes or no, that's my 394. And I then look at the dates. What do I get? Well, I find admitted to ICU has 3 categories: no, yes, and unknown. And then we have a date, recorded or missing. Well, it's quite nice that for most of the dates recorded, they were actually said to be in ICU and only one of them wasn't. That's really, frankly, a pretty impressive error rate. But what's a bit more worrying is this number here. Not having a date when they weren't admitted. Okay, that's quite good. Not having a date when they're unknown. Okay, that probably means they weren't admitted. But these 904, they've got no date of admission. That's not a very small proportion of the data we've got. It's almost a quarter. So at that point, you actually need to know something about hospitals and data to try to work out what's happening. Otherwise, you just forget, or you have to change your analysis for all of your data. So, okay. So let's for the moment assume that you can do something sensible. You can spend hours, which is what I did, looking at the individual dates, comparing dates for different things, trying to come up with your best estimate of what the date should be. And if admission to ICU is missing, the date of hospital admission is recorded and you get the hour and the minute, you can start doing some matching up and decide, okay, I've got the hour of the day when the person went into ICU, but not a date. But given that hour of the day is just after the hour of hospital admission, I can deduce that was the same day, or things of that ilk. So you can do some cleaning and thinking about censoring, and if there's no final date recorded, well, we'll just assume that the day the data was collected, the person was still in the system. But it's said that increasing age and comorbidity, such as obesity, are associated with a higher probability of death. Well, that's not going to be too difficult for age because we typically know the person's age. But what about obesity? Well, let's have a look at the data. So we actually have two fields, obesity clinical and obesity BMI. So 3/4 of patients had both fields missing. You might optimistically have thought, oh, well, they'll have one or the other. Unfortunately not. Clinical obesity is basically look at the person and say, so you might look at me and say borderline obese, or you might say not obese. Don't know if you can see enough of me to form an opinion, but there you go. But actually, when you start looking at the data, this is what's actually happening. We get unknown recorded for 426, but look at this. 7,000 of the patients plus just blank. So if you look at that, we've got 75% unknown. And then we've got some information, and I've deliberately put in these figures here where I've just used these 2,500 or so patients, and that suggests 20% obesity rate. Now, the other way is recorded body mass index, which is your weight in kilograms divided by your height in meters squared. So my body mass index is about 26, which is defined as borderline obese. And you can see that, well, the figures are not completely different. So I've mapped these according to the official categories, but we've got even more missing data. We've got similar proportions, and I know where to go and look up the statistics on people over 54 years of age, who are the majority of these patients. And a third of them, or at least nearly 30%, are obese. That's quite a bit more than 20%. And if you take the overweight, which is what borderline obesity counts as, 40%. So the one thing I know about these figures where I do have information is that they're misleading. They are not plausibly consistent with the population, particularly because we already know that actually hospital populations represent the less healthy part of the population, i.e. the more obese. So I pointed this out to my member of parliament, and she asked some questions in parliament which haven't been answered. And she wrote back to me and said, have things got better? So this is the most recent data, 16th of July. Have things got better? Well, there are not so many blanks. Looks quite good, doesn't it? Till you see what's happened over here. You've moved your blank to saying unknown. Your proportions of recorded are beginning to look a bit more plausible. But not all that much better when we look at the official recording. Okay, so is it going to matter? Can we do what the two things that are commonly done, probably particularly by people who are not applied statisticians? So one thing is saying, well, we'll just throw away all the missing data. We'll just assume that we can ignore it. Well, of course, that would get you only a quarter of your data. The other thing that's done is what's called imputation, which is to say, okay, we don't have obesity, but we've got age and sex. So we'll predict from age and sex. That's fine, but to do that prediction, you've got to assume that the data is missing at random given what you know. In other words, that you can just assume, conditional on your subsets, the data's missing at random. Well, is that believable? Well, let's have a look at this graph. So to talk through this graph, what I've done here is taken the day people are admitted to hospital and seen which of three things happens. They can be admitted to hospital and essentially be admitted straight into intensive care unit. It's about 25% of males, that's what happened, about 15% of females. Sorry, no, far less, sorry, that's far less of that, of the females, about a couple of the females. And what's happening with the men is that after about, let's say, a week, almost all the men who are going to get admitted to intensive care have got into there. So 40%, and it's only trickling up to below 50%. Different for the women, they get admitted to ICU over quite a long period, 30 days or so. Sorry, just realized okay. And then you can think whether they've left hospital. Now, this could have been left to go to a care home or anything else like that, but they're not in hospital and they're not in ICU. Or they may have died. So in terms of deaths, red is male. We're getting some more deaths, fewer deaths from females, far more females being allowed to leave. So we can see really quite different from male or female where we've got the data. But once we look at obesity, we could just look at red and blue, which is where the sort of pictures of, oh dear, people are much more likely to go into ICU if they're obese than not, comes from. And you can see, and we're now talking about 80%, within 10 days, 80% of people who are obese are in ICU. Whereas those who are not obese, 50%, very different. But look at this category, which is 3/4 of people, the missing. Now, if you think about it, if you sampled, if these missing people were just a random sample of the people from these two categories, you would expect things to lie between. If men on average are, 1.9 meters, women on average are 1.6 meters, and you've missed some heights, but you knew that your population had 10% women, 90% men, you would expect in that missing, the people were missing, to get some sort of appropriate weighted average between the two categories. That's just not what's happening here. The missing data is just very, very different. In fact, you might say, well, if the data is missing, the person's probably not obese, which means I should pull all these averages down, which might make sense for getting admitted into ICU. But what about the deaths? Well, if we look at the deaths, we're seeing a low rate of death amongst the obese people, higher rate of death amongst those who are not obese, and quite similar to the missing. And when we look at people who are discharged, so they're discharged alive, well, relatively few of those who are obese, okay. And here, perhaps, the missing and those who died are looking similar. But they're very different here. So what should I conclude about obesity and the implications of obesity? So if you want something slightly more mathematical, if you like, than I've been talking about, just talk a little bit about what I would like to do. So I didn't get the grant funding to do it. I'm one of many hundreds of disappointed people, no doubt. So what do we do about all of this missing information? Well, as I said, you can think about it, and the common expressions are missing completely at random, where, you know, that's what you would get if you did a simple random sample. You might have missing at random where you say, well, what I'm going to do is to try to get information on everybody aged over 80, but only 50% of people aged over 70, and so on. You then have got some idea of why things are missing, what the dependence is on whether you get an answer or not by sort of age and sex, and you can do something. But if you've got missing it not at random, if your missingness depends precisely on those characteristics of the subject, you're basically going to have to make assumptions. And it would be quite a good idea to do two things. One, be explicit about those assumptions. Two, check out the implications on your conclusions. And quite simple ways of doing that, to go back to this, would of course be to play around with putting all these missing people into the obese category. So if I pulled the red and black averages on ICU together, maybe we'd land up finding obesity had no effect. As I said, if I did the opposite, we would start finding a much bigger effect. And of course, that's the point at which you can essentially say, I don't know what's going on. I know I don't have reliable information. Of course, saying I know you don't have reliable information makes you extremely unpopular, because some people have to make decisions. And I appreciate that, but I'd rather somebody said, I don't know, I'm making the best decision I can from what I know, than kept saying, oh, we're following the advice of scientists, when all you're going to do is, I'm not suggesting scientific experts should have the last word, but frankly, neither should they be universally condemned as a group. The way we would actually want to look at these things and the formal definitions, if we say M equals 1 for missing, it implies Z is missing, and X we're going to have like age and sex for everybody. Missing completely at random just means the probability of being missing given X and Z, no influence of X and Z. Missing at random says, well, it might be differentially missing for men and women, but provided I know whether a person is male or female, I don't need to worry anymore, because, you know, 50% of men were sampled and 40% of women were sampled. I'll just adjust for that. But if you start getting into this characteristic, or even this characteristic, that whether or not you're missing depends on the variable you're interested in, you're really in trouble. And of course, it gets much more complicated once you start making this multiple dimensional. So if anybody feels like following up some of these ideas, chain event graphs are something that are really quite helpful, because they're a graph that's going to let you think about where might missingness turn up. And as I say, this is going to be a sketch, but imagine the idea that you want to think about what's happening in a person's life. And this is just a different example. Children and whether they use drugs in adolescence, and whether they have a hospital admission for physical ill health as a 20-year-old, young 20-year-old. And we can say, well, as a child, we were interested in their parenting. Did they have both biological parents? Did they have two parents, adoptive parents, or a single parent? Almost invariably the mother, obviously. And then we can say, did they experiment with drugs when they were teenagers? And were they admitted to hospital? And if we look at these things and this series of conditional probabilities, this is coded in color to say, well, actually, it doesn't matter what the structure of your family was at birth, that the probability of trying drugs or not is the same because these all have blue and red. But when we come to whether or not you've had hospital admissions, the two colors there are the same. So that's saying it's the same for two-parent families, no drug abuse, and the same for two-parent families, drug users, because those green, brown, but it's not the same for the single parents. The color that matches is no drug abusers. So to get to no hospital admissions at the green rate, there are various different paths, but we've got lots of redundant information. You can see that this subgraph and this subgraph are the same. Essentially what a chain event graph does is say, that's a bit inefficient, let's collapse them all into a picture which basically says, if you're in a two-parent family, then, and you don't use drugs, then you're going to have one rate of hospital admissions in the population age 20, and users will have a different rate. If, however, you come from a single parent family with no users, you'll have the same rate as a user from a two-parent family, and there's a different scenario from your third population. So, sorry, I forgot to turn my mobile off. Now, of course, what you might have is the kind of situation we've seen in the graph I showed you. Let's think of having children, adults, and old people, and think about the probability of ending up in ICU, which is pretty small for children. I should actually have made that smaller. Sorry, for non-obese and obese. We could have a relationship which said, if we know whether a person is obese or not obese, we have these kinds of probabilities of being in ICU after a certain length of time. But if that data is missing, people are much more likely to be not to be in ICU. And so graphically, essentially, if the data were missing at random, we can actually fit this graph to the data. And if that missingness lands up between our two other categories, it's at least reasonable to assume missing at random. But if we get this kind of pattern, which is what I tend to see, then we're back in the position of saying, well, once I start looking at my data, I have to realize that I should be very, very careful about making any claims about what happens with obesity. Now, of course, in the UK as well, there's a lot of concern about ethnicity. There are all sorts of complicated pathways. But the most common category we get is white British. But the next most common category is unknown and missing. That actually means we shouldn't be trying to make any claims on the basis of ethnicity. And that, of course, is a very unpopular thing to say. Applies also in discrimination cases. And I find that when I say that to people, they just say, well, we're going to have to make conclusions anyway, which is somewhat unfortunate. So I think there's quite a lot we don't know. I would much rather people were a little bit more honest about what we don't know, particularly, for example, about the quality of tests, the anxiety that is caused when you claim that all positive tests mean disease positive, and let people think there's a huge number of cases, when once you start testing large populations with low prevalence, you're going to have to be quite careful. There are also unknowns like social distancing. And why is social distancing non-directional? If I'm back to back with somebody, I think that's a bit different from being face to face, inside, outside, and so on. And what you tend to hear is people saying, oh, we've got to be safe. But if you want to be safe, you've always got risks and benefits. And my understanding is that Germany has been far better at trying to discuss the pros and cons of policies than the UK. There is a rhetoric in the UK that the only option is lockdown, and it's wonderful. There has not been anything like enough discussion of the impact on young people and the longer term impact of all these activities. We're going to have some natural experiments from around the world. Kenya has adopted some policies, Tanzania has adopted different policies, Sweden's adopted different policies, and I'm sure hindsight will be wonderful, but we shouldn't only be using hindsight, we should have been using data much more critically, much more quickly. What I said weeks ago with the once you get this kind of thing where you're getting this kind of stuff is stop trying to collect 100 plus fields. Get me a small amount of good quality data and we'll have a much better idea of what's getting on than a large amount of very poor quality data. But I'm afraid I've accepted that is a message that's incredibly difficult to ever get through to people. If I were to ask you, would you like to sit and collect all these fields, you'd say no, but you assume that somebody else is going to do it. Why? Why would I assume that somebody, okay, I should probably assume that other people are better than I am, but a little touch of realism wouldn't be a bad thing. So yes, I suppose that's perhaps a rather uncheering one. So I'll finish off on another idea of what's happening with respiratory diseases in the UK. Went up, dropped down, went up, dropped down. What do we know? Well, we know a little. Thank you.
Yeah, thank you very much, Jane, for this excellent talk. So I would like to go into the discussion. I think we should have plenty of points of discussion, and you raised some of them in between. Yeah, so for the discussion, yeah, you can use the little hands in the Zoom options, or you can also switch on your microphones again and say it directly. So yeah, are there any immediate questions? I know usually the discussion has to start somewhere. I just have to go through.
Luca?
Marcus, yeah.
Yeah, okay, yeah.
Yeah, am I correct thinking that basically there are many people in the UK that went into ICU units, and basically nobody in the hospital knew when they went in?
No, I wouldn't necessarily say nobody in the hospital knew.
Okay.
What I would say was it was not recorded.
Not recorded
on the data systems. Right?
Okay.
So what I'm saying is
Sounds really
the official data
Uh-huh.
That is made available to the
Uh-huh.
scientific advisors, has information missing.
Okay.
Right. So I gather from my colleagues in Manchester, within the hospital system, you can sometimes get more information, but it's this trade-off that different countries make differently about privacy and data access. You know, I'm pretty sure that my colleagues in Sweden will have much better quality data because they have a different attitude. You have bona fide researchers get access to data without individual informed consent. And it's a choice different societies make. And my experience is people very often try to claim, they just say, oh, but you must be able to, if the data's missing, you must be able to invent it. Well, you can invent it, but you can't do anything reliable.
Yeah.
And I have no idea what Italy or Germany would be like. I did hear that there were some considerable challenges in the Italian official health statistics.
Yeah.
Yeah. Well, at least we have just one site. Somehow it's called the protection, the civil protection site, and where the number of incidents and the number of people in intensive care units are collected basically every day. Now, I don't know if they made up those numbers, but
yeah, it still has to be collected.
Yeah.
And forgive me for being cynical, but from what I know from my Italian colleagues, there are quite a few problems along the way.
Okay. Yeah, no, I'm sure about that.
You know, it's
okay.
It's not an easy job.
No.
No. Yeah, let's go to Steffen.
Hi, thank you for your nice talk. It really raises a lot of questions about data itself. For example, you investigated the missing of data, but have you analyzed the if the data is correct or not, or there are errors in the data itself?
Some of it I've been able to do. So again, this is, you know, I've sort of given up trying to get things published very quickly. Yes, so when I went through those 100+ variables, I mean, some I didn't try to pay attention, but yes, case by case, I would look at the logical implications of things. You know, is the date of admission to hospital before or after the date of leaving hospital? If somebody is recorded as having severe asthma, are they also recorded as having asthma, or is there a contradiction there? So, you know, the trouble is that it isn't actually the kind of thing you can easily get a machine to do by machine learning, because a lot of it requires on the context and the understanding. So because I've worked quite a lot of with medical data, I can read, you know, the ECMO and the ventilation and the nasal and so on. And I've got an idea of the logical structures, and I can set up logical tests. But that means that if I get a data set, you know, it's at least 2, 3, probably 5 days hard work for me to clean the data and try to correct it as far as I can. And I can't actually go back to, you know, in a less urgent thing, you would go back to the people and say, have you got more information? Can you go back and find out about that? You don't really have that option here. So yes, I mean, I have done, and I have fed back to the group sort of alternative analysis with some sensitivity analysis. How much difference does it make? One of the other things we know is huge regional variation in the UK in admission to hospital, how people work. I mean, that's even within England, let alone England, Wales, Scotland, Northern Ireland.
Can I ask you one question about this? So in a sense, it's about, you know, how can you check the quality of data? So would you, for example, the first question would be, would you support a policy that in such a, you know, in such a case where urgency is required, there would be special teams that go to hospitals and support the
I
data
mean, that
collection.
does, that actually does, I mean, that does happen. There is legislation, I've forgotten the number, I used to be able to quote the numbers of the legislation. There is legislation which gives people exemptions from requesting informed consent. And effectively that has been invoked. The longer term solution is, the only way you get good quality data is if it's used and the people who are collecting it can see that it's useful. So an older colleague with whom I worked on cerebral palsy, he made a point when papers were published of letting the clerical staff know, and he actually went and has given talks to the clerical staff saying, this is what your work has enabled us to do. And, I try to give credit to the staff as well, but there isn't enough of that. Human motivation in all of this is important. And, if I'm sure the clerks know, because I've spoken to some of them, a lot of the stuff is nonsense, but why bother? Because it's never meaningfully used. If it was being well used for statistical quality improvement, not target setting, you would stop collecting stuff that wasn't important. You would collect the stuff that was important properly. You would feed it back and people would see their job was worth doing and doing it.
But for example, if you look at the temporal dynamics of missing or low quality data, I think you could try to do something like that.
That's what I as soon as I saw this stuff, I put in a very rapid request for time and money to do that, saying we need to see what's happening. I've got the contacts to feed back to the staff to say, stop trying to extract 100 variables. Concentrate on this, 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 and this. That will be much more useful. But, people make their choices, research grant committees and everybody make their choices, and that's.
No, I mean, I was actually more precise in my question in the following sense. So, the underlying hypothesis I had was that if the health system at a certain time is overwhelmed, then of course the staff is not able to record things, and then things are becoming better when when the stress is a little bit diminished afterwards.
Yeah, that's
could you measure that in a sense from the data?
I did, but I mean, if you looked at what happened with obesity, which is in the rhetoric, the Prime Minister's talked about it, the way that changed was from being left blank to being recorded as unknown.
And that's all, yeah.
It's a certain improvement, not a very inspiring one. And if you've got 5-10% of data missing, you can it's probably not too bad. But once you're going up to 10, 20, 50% missing, you really should be saying, how can I improve the quality of the data? Essentially what you should be doing is saying, instead of one person spending 10 minutes on one patient to try to get all of this, each of my people, my people will spend 3 minutes trying to get a little bit of data, but 3 separate people will extract for each patient, cross-match, improve the quality on the core variables. You could at least try that, but
well, I think that would be the only way, because you cannot tell the people in an intensive care unit to record data or so. You need extra people in that instance.
And I mean, it does vary hugely across. So I think the Cambridge Teaching Hospital has actually implemented handheld devices where you can get much more accurate. Well, you can get entry, you can see the records, you can get things flagged up as whatever. But again, you know, it does take time to get people to accept the value of those sorts of things, and to accept that even that needs checking.
Yeah.
May I ask?
Yeah.
Excuse me. So do you have somehow a list of somehow key data that you would like to have? The minimal key data.
If I was working on that thing, I
Yeah.
would want, I'd like the dates to be accurate. Thank you very much. That would help. The dates, age, sex. I think it would be sensible to record height and weight.
Mm-hmm.
Okay, it's not that easy, but it's not actually that difficult either. You know, okay, if a person's on a bed, you measure their length. It doesn't have to be desperately accurate. If you got their weight and their height, I think that would be useful. And then I would only look probably for the most common things. I would want to find out diabetes or not, if you could. Cardiovascular or not, if you could, or if you like hypertension. And yeah, you know, renal, liver, cancer. But I would stop. I would want to be getting maybe 15, 20 variables at most. But I know from other areas that, and from being on research grant panels, it's almost impossible to convince people that they've got a choice between 95% completeness and 20 variables. But they'll want 200 variables, and they'll prefer to have 200 variables with 40% completeness, and all sorts of selection biases. But you know, unless you're a, I don't know, an experienced statistician, you know, I've had quite a lot of experience of this. People just, I suppose we all do it to some extent. If the fact is inconvenient, we can just choose to ignore it.
Well, and then let me just maybe ask one question about this. So you had a very nice exposition about how you can generate missing data. And so you had these different categories. I have a specific mathematical question about that.
Yeah.
What about if you would introduce you know, a weighted kind of weighted sum between these things?
That's
and
very good. So that's actually one of the simplest descriptions of missing at random. So not completely at random, but the missing
exactly,
at random.
yeah, exactly, yeah, exactly.
So that's what I'm saying. If you knew that there was a certain pattern of missing, that conditional on age and sex, it was missing at random, then you would use age and sex and, you know, BMI for the ones you did know to impute for the ones you didn't. So you do the weighting, but it depends on that assumption. And once you can see that that assumption is false, it's just, you know, just life, you know. If you start being fanciful about what you'd like, you'd probably say, well, why don't we just imagine there was never coronavirus?
Yes, of course.
So you have to do the best you can, and you know, sometimes it may well be that you say we don't have hard clinical information about obesity, but it's a reasonable thought. We might want to go with that in the meantime, and if it's important enough, we'll do another study that really tries to discover it. But I don't think spending your energy on elaborate ways of trying to impute the data helps.
Well, is there any other question?
Yes, we are on imputation on data. Just when we have an expert at hand. For example, the Robert Koch Institute uses some imputation to create these nowcasting methods to correct the date of coronavirus incidents. What do you think of this method?
I think with all of these things, the thing that I always think is important is to be explicit about what you're assuming and why you're assuming it. And ideally, to also say, I could be wrong. So if I take, and again, you know, you can rapidly multiply things, but you can say, if I take a plausible good and bad case, what will happen? Of course, the danger with that in the UK is our media always leaps on the worst case scenarios and presents it as a certainty. You know, Ferguson predicted 130,000 deaths from new variant CJD. There were 120. Not 120,000, but 120 against a prediction of more than 100,000. So one of the other long-term challenges for the Royal Statistical Society, the Royal Society, is trying to get journalists not to always, you know, the best estimate is the best estimate. Could you please talk about that? Yeah.
Yeah. So any other questions? No, then I would like to thank Jane again for this wonderful talk.
Thank you, everybody, for attending. Appreciate it. Yep. If you have any bright ideas overnight or anything, do let me know.
Yeah, we do.
Yeah. Thanks very much.
Yeah.
Okay. Bye.
Bye.
Bye. Bye. Bye, everyone.
Bye.